Well, welcome back to College Algebra. I hope you have enjoyed your extended spring break and are ready to get started with video lectures for the rest of the semester. Today we're going to begin with section 3.4, and I want to remind you, hopefully you've looked at the syllabus, the updated syllabus, and you've looked at the updated calendar and listened to that video, so you know that homework in quiz number 8, which was open before spring break, and many of you actually did, it was sections 3.1, 3.2, and 3.3. This is now due. Both the homework and the quiz are due this coming Friday. A week from actually today. I'm doing this on the 20th. It is March the 27th at 11:59 p.m. Since some of you got the 2 attempts on this quiz before spring break, we decided to still allow 2 attempts on this quiz, but this will be the last quiz that is all multiple choice and has 2 attempts. So take advantage of that. Make sure you take the quiz twice so that you can get the best grade possible, keeping in mind that you are still bound by the honor code when you take your quizzes. So hopefully you'll get 100 on the homework and a really good grade on your quiz. So let's go ahead and get started. I will tell you that the homework for this is homework in quiz number 9, which is sections 3.4, 3.5, and 3.6 will open on Monday the 23rd, which is probably when you're watching this, or I hope you are, and it will be due on I'm trying to look at my calendar here, sorry, on Friday, April the 3rd. So Friday, April the 3rd at, again, 11:59 p.m. All right, so let's get started with this material. So this first section we're going to talk about today is section 3.4, and it's talking about transformations of functions. So I'm going to kind of expect you to remember some basic, what I called toolbox functions that we talked about before spring break, and things like the absolute value of x and y is equal to x squared. So, but we're going to talk about how to slide those and move them around and translate those. So this first one is we're going to talk about vertical shifts of a function. Vertical shifts mean that we move our basic toolbox function either up the y-axis or down the y-axis. So you can see here that this purple graph is the function f of x, or y is equal to the absolute value of x. We've talked about that v-shaped function. If I add 3 to the end of that function, it takes every single point and it moves it up 3 units. The easiest one to kind of translate is that turning point, which is at 0, 0. If I take that absolute value function and I subtract 3 from it, then it's going to take that entire function, it's going to shift it down 3 units. So kind of in general, if you have any type of function and you add a constant to the end of it, it's going to shift it vertically upwards. And if you subtract a constant from it, it's going to shift it vertically downward. So it'll basically take every point. So if I had the point here 1, 1, then I'm going to take that 1, 1 and it's going to shift that 1 down 1, 2, 3 units, and so now I have the point 1, negative 2. So if I take 1 minus 3, then it's going to be negative 2. So that kind of gives you an idea. Most of these problems will be multiple choice. There'll be a few where you actually have to sketch a graph, but you'll have to just plot some points. So let's look at this first function. This is g of x is equal to x squared minus 1. So our basic function, our starting function, is y is equal to x squared. Remember, that's our parabola, our u-shaped function that would normally turn here at 0, 0. We talked a little bit about that turning point being the vertex, but now since I've subtracted 1 from it, then I'm going to shift this, and I think it's a good idea for you to write down where you're shifting it. So it's going to shift 1 unit, and because it's subtracted, it's going to shift 1 unit down every point on there. So rather than turning here at 0, 0, it's going to turn down here at 0, negative 1. rather than having a point at 1, 1, it's going to have a point at 1, 0, and having a point at negative 1, positive 1, it's going to have a point at negative 1, 0, and literally everything is going to shift down. Let's see if I can cheat and draw some really nice lines for you here. So here's this side and this side. You guys all know I can't draw, so be happy that I actually managed to get straight lines on there. Sorry. Okay, so this is my new function, and that's all there is to this. So we're going to do that for every single one of these. So number 2 here, the basic toolbox function is the square root of x. Remember we talked about that square root of x is kind of that sideways half of a parabola, and in this case we're going to shift it how many units? Hopefully you're answering at home. We're going to shift it 2 units, and because it says plus, we're going to shift it 2 units up. You can participate too. I just can't hear you. So rather than starting here at 0, 0, which is where my square root of x would normally start, it's going to start at 0, 2. Your point that was at 1, 1 is now going to be at 1, 3. And really and truly, as long as you know where to start it, your graph is going to just kind of go up like this. The big thing is, especially on the multiple choice, is that you know where it's been shifted to. So your other options that will be wrong answers would be shifted to the right, or shifted to the left, or shifted down. So just watch out for that. The plus 2 after your square root tells you you're going to go up 2. Okay? All right. You can always plot points too, so if you just totally get stuck and don't know where to go, you can always make a table of values. There's nothing wrong with that. Just would prefer that you be able to just translate it, but there's absolutely nothing wrong with a table of values. Okay. The absolute value of x, and now we're going to have minus 3. This is our function h of x. Our basic toolbox function is that's the absolute value of x, and we're going to shift this, and you should have seen this one before, 3 units, and because it says subtract, we're going to go 3 units down. So rather than turning here at 0, 0, it's going to turn down here at 0, negative 3. Let's move this down just a little bit. So at 0, negative 3. Rather than having a point at 1, 1, we would now have a point at 1, negative 2, and at negative 1, negative 2. And then we'll have our lines here that go like this, and like this. Sorry about that. All right, and so that's our graph of the absolute value of x minus 3. All right. So let's look at this next one, x cubed. We haven't spent a whole lot of time talking about x cubed function. So the x cubed function looks like this. It's kind of this little squiggly line. It squiggles through the point 0, 0. So that's what x cubed is going to look like. Because I have plus 1, I'm going to shift this function 1 unit, and it's going to go 1 unit upwards. So rather than twisting here at 0, 0, it's going to twist here at 0, 1. Really and truly, that's what I want you to be able to do, and it's going to come up and it's going to kind of twist through here, and it's going to go up like this. So like I said, you can plot some points, you can do a table of values, but this is my general shape of my function. This one will definitely be multiple choice. Okay. All right. So the next thing we're going to do is talk about horizontal shifts. One of the things that I want you to notice, if you go back to, I'm going to go back a couple of slides and talk about this function where I had the absolute value of x and then plus 3, minus 3. These were outside, what I call outside the function. These that we're talking about now, which are our horizontal shifts, notice that that plus 3 is inside your absolute value function. This is x minus 3, which is once again inside my absolute values, and that's what's telling me we're shifting side to side, or that horizontal movement. So if it's added or subtracted to the function itself, it's vertical because we're changing the y values. Here we're changing the x values, and so that's going to make it side to side or horizontal. Now it's going to be just the opposite of what you might think. So with the plus constant, it's going to shift to the left, and with the minus the constant, it's going to shift to the right. One thing you can do, so for example on this x plus 3, if I take x plus 3 and I set it equal to 0, then that tells me I'm going to be starting at negative 3, and that might be a little bit helpful if you're trying to decide which way to go. Once again, you can always plot points. If I put in negative 3 here, I'm going to get 0, and that tells me that this is where I'm going to start. Okay. All right, so let's see if we can do a couple of these, and then we'll start putting some things together. So my basic toolbox function is this square root of x, because I have the square root of. Notice that my square root extends beyond my -4, so it's not what we did a while ago, the square root of x and then -4. My -4 is inside my square root, and so this is now going to be 4 units, and I'm shifting it to the left or right. We're going to shift it to the right because I told you on the horizontal it's just the opposite of what you expect. The other thing you can do is talk about the domain of this function. So the domain of this function, if you remember our square roots, we took what was inside the square root and said, okay, it has to be positive, greater than or equal to 0. If I add 4 to both sides, I get x must be greater than or equal to 4. And so my domain starts at 4 and goes to positive infinity, which does help us remember that it's going to start here and go to the right over this direction. So same thing either way, whichever way might kind of helps you remember this, but we are going to start here, and my square root function looks like this. And so that's going to be my graph there. Let's look at x plus 3 squared. So again, I've got my quadratic function. Y is equal to x squared is my basic toolbox function. And this one is going to move 3 units, and it's going to be to the, because I'm adding this, it's going to be to the left. Okay. Once again, if you set x plus 3 equal to 0, it would remind you that you're at -3 when you do this. So rather than turning at 0, 0, it's going to have this turning point at -3, 0. For this one, you may want to pick a second point, and because this is the one that you might actually have to graph, I would either select, once you figure out the turning point, I would either select -2 or -4, usually 1 unit to the left or 1 unit to the right. I'm going to select x is equal to -4, and then I want to find the ordered pair that goes with that. So just reinforcing that I'm plugging this into my function, -4 plus 3. I'm going to square that. This is going to be -1 squared, and so I'm going to get +1, and so that reminds me then that my point is going to be -4, +1. So I'm going to come all the way over here, and I'm going to plot this point. Because this is one of those functions that has some reflexive properties, then you also could go ahead and plot a point over here. Either way, my les plus is going to ask you to plot at least one additional point other than the vertex to select the fact that you do have a quadratic function and plot one additional point. So you know where to kind of go from there. Okay, very nice. Our absolute value function, so our basic function here is that absolute value, that V shape again. However, we're going to shift it 1 unit, and we're going to move it to the, you guessed it, we're going to move it 1 unit to the right, because it looks like it should be negative, so we're going to move it over here. So rather than turning at 0, 0, it's going to turn here at 1, 0. If you wanted to pick a second point, this one's also going to shift to the right, and this one's going to shift to the right. And then we have our very nice V shape here. That looks terrible, sorry. Okay, we'll try that again. There we go. All right, so moving along, the next thing we're going to talk about is what we call x-axis reflections. If you see anything about y-axis reflections, we are not going to do those in this class. We are simply going to reflect functions about the x-axis. You can do both of them, but the x-axis reflection is what happens when we put a negative in front of the function. So the absolute value of x, and remember for this function, it actually has a range of all positive values. We can close this off, 0 to positive infinity. The range for this function, and we'll look at this one, the range for this function is going to be -infinity to 0. So it's all these negative values. So notice that the whole thing just flips upside down, and that's really what we're going to be doing, is flipping it upside down. But just to kind of give you an idea, put some things together for you, right? So we're going to look at -x squared. So rather than x squared going up, -x squared is literally just going to flip upside down. So when I flip this upside down, rather than opening up, it's still going to have that turning point at 0, 0, and it's going to flip downwards. And we're going to do both sides of this. If you wanted a second point, You could pick x is equal to maybe 1 and find g of 1. When we do this, notice that that negative is not being squared, and so I have the point negative 1, negative 1, and it's going to be right here. And that's going to be my graph, right? So just remember that the negative in front flips it over, okay? All right, so the next thing we're going to talk about is what we call vertical stretches and compressions. This is what happens when I actually just multiply something in front of my function. There are two different types of things, so we call it a vertical stretch if it makes it what I call a little bit narrower, it's closer to the y-axis, and this is if the number in front of my function is a number which is larger than 1. It doesn't have to be a whole number, but it's just a number that's larger than 1. If the number in front of my function is between 0 and 1, so typically some type of fraction or decimal, then we call it a vertical compression. And you will be asked to identify if it's a stretch or a compression based on whatever the constant is in front of the function. So I like to think of this like the 1/5 here. It makes it a little bit wider. It makes it go away from the y-axis or closer to the x-axis. Okay. The easiest thing to do for these functions to get a very accurate picture is to know, one, that it's not shifting it, it's not moving it side to side or up or down, it's not flipping it over, and then maybe to plot a couple of points. So I do like to plot the points for these compressions and stretches, and that's what we'll do on these. So for the absolute value of x times 3, this is going to be a vertical, you guessed it, stretch of 3 units. Some of these you actually just get to select. It's kind of a sliding scale on MyLabs Plus, so watch out for that. You literally get to just pick wherever it slides to. So for these though, we're going to pick a couple of points. So x and y being our g of x, we're going to select -1, 0, and 1. If I plug -1 in here, I'm going to get a value of +3. 0 is still going to be 0, so that's not going to move. And if x is +1, I still get +3 when I plug those numbers in. So this is where it doesn't move. My turning point is still at 0, 0. But rather than having a point at 1, 1, it's going to be all the way up here at 1, 3. And here it's going to be at -1, 3. So you notice how this graph is a little bit skinnier, a little bit narrower than the one that we did earlier where we had that absolute value. Let's do this a little bit better. So a little skinnier here, a little skinnier here. So it's kind of a narrower graph there. Right? So if the coefficient in front of my function is a fraction or a number less than 1, then I'm going to have that vertical compression. So we're going to call this, we're going to identify this. So this is my vertical compression. That's an M, sorry. Compression of 1/2. So again, I'm going to pick some values for this. I'm going to select -1, 0, and 1. Those just make kind of nice values. If I square -1 and multiply it by 1/2, I get +1/2. 0 is still going to give me 0, so that's not translating up or down. And 1 is going to give me +1/2 when I plug it in here. So 0, 0, it's not shifting. But at 1, I have a y value of 1/2. At -1, I also have a y value of 1/2. And so my graph is going to be significantly wider than it would otherwise. It still does curve down here. This is not my absolute value function. It is still curving down here because it's quadratic. Yeah, I know I can't draw either way. Okay. In class, face-to-face, or online, I still can't draw it. Sorry. Okay. So when we combine some of these transformations, we really try to look in this order. We look for the horizontal shifts, the ones that go side to side. Then we look to see if it's been stretched or compressed. Then we look about the reflection about that x-axis, and the very last thing we're going to do is our shift up or down. If we do that first, then it just makes it a little bit harder to do. So I like to save this one for the very last. It just kind of keeps you out of trouble. So if there is a reflection, we're going to reflect it before we shift. Okay, so if you'll kind of keep those in order. So we're going to look at this function. So the first thing we're going to do is look at the horizontal shift. So this is my horizontal, I probably can't spell today, horizontal shift. So we're going to go 1 unit to the left. That's what that +1 does. Okay. There is no stretch or compression. So no vertical stretch or compression because there's no number in front of this other than 1. We also do not have, there is no reflection. If there was a reflection, it would be a negative here. And so then the next thing we're going to look at is the -2. And so then the last thing we're going to do here is we're going to do a vertical shift, and we're going to go 2 units down. Okay, so that's the very fourth thing we're going to look at. So even though there was nothing here, I'm still going to kind of label these so that you can go back to that previous page. So we'll start by, we know that our basic function is y is equal to x squared, so it's my quadratic. My quadratic is going to be shifted 1 unit to the left, so at -1, and then down 2 units. So rather than turning here at 0, 0, it's going to turn over here at -1, -2. Okay. Now for a second point on this graph, and that would probably be really nice, I'm going to use x is equal to, what do you think? I'm going to go x is equal to 0. Why did I pick 0? Because it shifted over here to -1, and 0 is 1 unit away from that -1. It just makes for a really nice point. So we need to find f of 0. So we're going to have 0 plus 1 squared minus 2, and this is going to give me 1 minus 2. And so f of 0 is going to have a value of -1. And so that point is going to be 0, -1. So here at 0, I have this point of -1. I could plug in -2. I would also get the value of -1. And so then my graph is going to look something like this. Once again, it kind of wiggles. Sorry about that. And there we go. All right. So we could find intercepts if we wanted to. I'm not trying to get that picky on these. I just want you to really be able to identify the shifts in these, any reflections or compressions, and be able to sketch the general graph. Okay. All right. So this one, we're going to start off with that same kind of thing. We're going to start off by looking at the first thing. So we have a horizontal shift. I'm just going to kind of abbreviate that. We're going to go 1 unit to the, because of the -1 here, that's going to be 1 unit to the right that we're going to be shifting it. So the next thing we're looking at is the number in front of this absolute value. There's a negative, but no number other than 1. So there's no stretch or compression. All right. And then the next thing I'm going to look at is the reflection. And so there is an x-axis reflection, and so we'll do that before we shift it up and down. Okay, so we'll flip it. And then the fourth thing we're going to look at is the fact that there is a vertical shift, and it's going to be 2 units up. Okay, so let's go back. Remember, our absolute value is that V shape, and so I'm going to take that absolute value and I'm going to shift it 1 unit to the right. So rather than turning at 0, 0, it's going to start off over here at 1, 0, but now it's going to be flipped upside down. And so I'm just going to kind of do this before I actually shift it up. So now that's my reflection. I have to flip it over, and so now I'm going to take this point here and I'm going to shift it up 2 units. And so this is where it's going to turn at 1, 0, and then it's going to flip upside down like this. And so rather than going up, we're going to go down. Okay, and that's going to be my graph. All right, so we moved it 1 unit to the right, we flipped it upside down, and then we shifted it 2 units up, and that's going to be my graph. Okay, I know you got this, so we're going to do a couple more. All right, so my basic toolbox function here is y is equal to the square root of x. So let's start with our shift to the left. Yep, you got it. So we're going to go 3 units to the left because of the +3. There is no stretch or compression, so no stretch or compression. All right, there is no reflection. Just getting you to remember to think through these things, so no reflection. And then finally, we're going to shift it 2 units up. Okay? So if we go back and we think about that absolute value is going to be that kind of curve to the side. So it's going to start over here at -3. Remember, if we talked about the domain of this function, we would be saying x plus 3 must be greater than or equal to 0. So x must be greater than or equal to -3. So that just kind of verifies that. So, but it's not going to actually sit here on this x-axis because I have to take it and I have to move it up 2 units. So it's going to have this kind of starting point here at -3, 2. I didn't have any other reflections or anything, and so my graph is going to look like this. Okay. All right. Moving right along. So now I'm going to get you to write a function. So this one says that the graph below was created by horizontally shifting one of the basic functions. Identify the basic function and write a new function which describes that graph. So the basic function here, hopefully everybody's figured out that the basic function is, you guessed it, x squared. All right, so now we're going to call our new function g of x just because. Remember, with the horizontal function, are we adding or subtracting to the end or inside? All right, for the horizontal shift, we are doing that movement inside. So we're going to have a parentheses squared, and we're going to have x. We know that it moved to 5, so now the question becomes, is it x plus 5 or x minus 5? Remember, the shift to the right means that it's going to be minus. And so I have x minus 5, and then the whole thing is squared. Remember, inside the parentheses is the horizontal shift, so horizontal is inside the function, okay? Vertical would be outside. Okay? And remember, the inside movement is the opposite of what we would expect. To check it, x minus 5 equals to 0 gives me x is equal to 5, and that's where it's sitting. And this is all you have to do. This is my new function right here. There's my answer. Okay? Right? Let's do one last problem. So this one is same kind of directions. This one, however, was created by shifting vertically. So if you remember, vertical shifts are, yep, you remembered, outside the function. Okay, so outside of our function, what is our basic function here? It's not x squared, and it's not the absolute value. You got it. It is the square root of x. And so let's call our function f of x just for a little bit something different. It's going to be the square root. Make sure you kind of close out that square root. You can't do anything after that. It shifted, and it's a 2 units. And remember, vertical is really true. So we're going to pretend this is actually at -2. Sorry about that pretty picture there. So the square root of x and then minus 2. Okay, so because it moved down here. Right? Now if I plug 0 in for x, I get the square root of 0 minus 2, and that tells me 0, -2 is going to be my point. Right? I hope you have enjoyed this introduction to transformations of functions, and you can get started on your homework, and we'll be back later for the next section, which is section 3.5. Have a great day.